Welcome to our channel Circuits Analytica. In this video, we will be discussing about first order active wide band reject filters. This is the block diagram of a wide band reject filter. The wide band reject filter consists of an active low pass filter and an active high pass filter. The outputs of the active low pass filter and active high pass filter are fed to the two inputs of a non-inverting summing amplifier. A wide band reject filter consists of a low pass filter, a high pass filter, and a non-inverting summing amplifier with two inputs. Cutoff frequency of the low pass filter is denoted as FL, and cutoff frequency of the high pass filter is denoted as FH. This is the diagram of a wide band reject filter. This wide band reject filter is constructed using three operational amplifiers A1, A2 and A3. Operational amplifier A1 along with resistors R1, RF, RL and capacitor CL forms an active low pass filter. Operational amplifier A2 along with resistors R1, RF, RH and capacitor CH forms an active high pass filter. Operational amplifier A3 along with resistors of value R and 2R forms a non-inverting two-input summing amplifier. So now let us consider the case when frequency of the applied signal is greater than 0 but less than the cutoff frequency of the low pass filter FL. So first of all, let us discuss about the two capacitors CL and CH. As frequency of the input signal is less than the cutoff frequency of the low pass filter, these two capacitors CL and CH acts as open circuit. As capacitor CL is open, the voltage at the non-inverting input of op-amp A1 is equal to Vin. So output of op-amp A1 is equal to Vin dash, which is equal to Vin into 1 plus Rf by R1. Capacitor CH is also open. As capacitor CH is open, voltage at the non-inverting input of op-amp A2 is equal to 0. So output of second operational amplifier is equal to 0 as its input is equal to 0. For the two-input non-inverting summing amplifier, one of the two inputs is equal to Vin dash and second input is equal to 0. So output of this two-input non-inverting summing amplifier is equal to Vin dash. Now let us consider the second case when frequency of the input signal is greater than the lower cutoff frequency FL and less than the upper cutoff frequency FH. As frequency of the input signal is greater than the lower cutoff frequency FL, capacitor CL acts as a short circuit. So non-inverting input of op-amp A1 is pulled down, or non-inverting input of op-amp A1 is existing at ground potential. So output of op-amp A1 is equal to 0. Capacitive reactance XCH is very high. So capacitor CH is represented as an open circuit. So current flow through resistance RH is equal to 0. So voltage at the non-inverting input of op-amp A2 is equal to 0. So output of second op-amp A2 is equal to 0. So for the two-input non-inverting summing amplifier, both inputs are existing at ground potential. So output of the non-inverting summing amplifier is equal to 0. Now case 3, when frequency of the input signal is greater than or equal to upper cutoff frequency FH. So capacitive reactance XCL is very small. So XCL is replaced with a short circuit. So non-inverting input of operational amplifier A1 is pulled down, or potential at the non-inverting input of op-amp A1 is equal to 0. So output of op-amp A1 is equal to 0. As frequency of the input signal is greater than or equal to FH, capacitive reactance XCH is very small. So input of operational amplifier A2 is equal to Vin. So output of operational amplifier A2 is equal to Vin dash, which is equal to Vin into 1 plus Rf divided by R1. So for the two-input non-inverting summing amplifier, the two inputs are 0 and Vin dash. So output of the non-inverting summing amplifier is equal to Vin dash. Now this is the frequency response of a wide band reject filter. The cutoff frequencies are denoted as FL and FH. For frequencies greater than or equal to FL, output is 1 plus Rf by R1 into Vin. Between the cutoff frequencies FL and FH, as output of the active low pass filter as well as output of the active high pass filter is equal to 0. For the non-inverting summing amplifier, both inputs are existing at 0, so its output is equal to 0. And when frequency of the input signal is greater than FH, output of the op-amp A2 is equal to Vin dash, and output of op-amp A1 is equal to 0. So output of the non-inverting two-input summing amplifier is equal to Vin dash. So here we can say that all frequencies between FL and FH are rejected by the wide band reject filter. Thanks for watching Circuits Analytica. Enjoy learning. Please comment, like, share and subscribe our channel.